Alright, so this time what we're going to do is compute the indefinite integral secant cubed. So indefinite integral, I'm not worried about the bounds at all. All I want to do is crack the antiderivative egg. This is the game I really enjoy. When they put bounds, then we have to suck up the yolk, and you can do that eventually. I don't really even enjoy that. Numbers are hard. I like to crack antiderivatives. So what we're going to use is integration by parts, it turns out. So when you're given a transcendental function, or some of these new ones, or this is one of the cases where technically tan to the 0 is there. So this is a product of tans and secants, and we have to do the special outlier cases where we have low powers of secants or tans and the other one missing. So long story short, the first thing I'm going to do is use exponent laws. 3 is 2 plus 1, and then I'm going to split them into secant squared times secant. Why I've done that is when you want to use integration by parts, essentially I've seen other mnemonics, the engineers out there. I know what you're doing. I don't know what you're doing. Stop using mnemonics. So what you want to think about is, who can I differentiate and who can I integrate? I know how to integrate secant squared, so I'm going to let that be dv. This one, I know how to differentiate the crap out of that, so we're going to let that one be u. The thing I can differentiate, I let u, because then I can differentiate it, and then immediately, so what that's going to do is, u is secant x, so du is secant x tan x. dv is secant squared x dx. Technically we're integrating both sides, and by the fundamental theorem of calculus we're going to get that this is v is equal to tan x. Once I have that by integration by parts, secant cubed, or secant times secant squared, becomes u times v, secant x tan x, minus the integral of v du. So I've got v and du, and so tan is tan squared, so I get tan squared x secant x dx. Once I have this, now we're going to use the Pythagorean identity, one of its daughter identities. By dividing by cos, we get tan squared plus 1 equals secant squared, or tan squared is secant squared minus 1. So this equals now our integral. This is the clever trick we're also going to do right away. This integral of secant cubed is equal to secant x tan x minus the integral of secant squared x minus 1 times secant x dx. I do not want to compute Lebesgue integrals, so I want to compute Riemann integrals. So the Riemann integral is equal to this. This symbol is meaningless without, it has some meaning, but I don't want to do measurable functions or the Lebesgue integral, so pass. That's definitely at least one other video. Now I get to distribute. Now there's voices everywhere. Now there's voices everywhere all the time. That was the G version. I'm going to distribute the secant onto this, equals secant x tan x minus the integral of secant cubed x minus actually dx, and then I'm going to distribute the negative and write this as integral of secant x dx. So what I notice is this is the same integral, secant cubed and secant cubed. So I'm going to bring it to the other side and solve for the appropriate integral also, which first year students really do not like to do. We're solving this for, that's like half edited, I only wrote out what happens when we blew it. Secant cubed is equal to secant tan minus the same integral, secant cubed again, plus secant x. What I'm doing is bringing this over to the other side, so I have two of them, and then we have plus the integral of secant x dx. This can either be another video, or I'm going to quickly do it now. The dirty trick for this is secant x is, you can think about this, ponder about this, I stole it from someone else. So what this is you multiply by secant x plus tan x over secant x plus tan x, and then I let u equal secant x plus tan x. So this becomes the integral of 1 over u du, and then I get natural log of the absolute value of secant x plus tan x, so plus c. So this now becomes magically 2 times the integral of secant cubed x dx equals secant x tan x plus the natural log of the absolute value of secant x plus tan x plus c, or the integral of secant cubed x dx is equal to 1/2 secant x tan x plus 1/2 the natural log of the absolute value of secant x plus tan x plus c. Oh, no mic drop.